Hello guys and welcome back to my channel. Okay, today's video we're going to be looking at like types of graphs, okay? So we're going to be looking at examples for linear, quadratic, cubic and reciprocal graphs. So this is going to be like a nice short video like introducing the types of graphs that we come across here in GCSE and maths actually, and also A-level maths. Okay, so first off, actually, so I've got like a line here actually. Okay, so this is what I call like a straight line graph. Okay, so it actually follows. Okay, it follows the idea of y equals mx plus c. So this is what I call like a linear graph actually. So if you look here, we've actually got like a power 1 here. Y equals mx. We've got y to the power of 1 here. So we've got y equals mx. So the key part here is x to the power of 1. Okay, so x to the power of 1 means it's going to be linear. Okay, so that's what's meant by like a linear graph. Now, m in this case just means the gradient. Okay, so that just means how steep it is actually, okay, and it can be worked out by the change in y, which is this part here, divided by the change in x. Okay, so I'm going to just put that as delta y and delta x. So delta just means change. And the plus c is where it crosses on the y-axis. So that's my plus c there. Okay, so that's my y-axis, that's my x-axis, and y-axis, okay? So that's what I call like a linear graph, okay? If I had like a line coming down this way, then it would have what we call like a negative gradient. This has got a positive gradient because it's going in this direction, okay? And c can take any value here between negative infinity and positive infinity if you're interested, okay? So that's where it crosses on the y-axis, okay? Right, next one. This is what I call a quadratic graph, okay? So it follows y equals x squared, okay? Quadratic, okay? So imagine, x squared, so power 2 means that I'm always looking at quadratic, so it's always going to be like this shape, okay? Again, if it was this shape, then it'd be like a negative x squared, actually, and so on and so forth, okay? So that would be my graph actually here. So if you're interested here, so it follows the rule y equals ax squared plus bx plus c. So the plus c is where it crosses on the y-axis. Okay, the ax squared plus bx, that just tells me how steep it's going to be. Okay, from there to there. Okay, last two graphs now. Okay, so this one is just like a cubic graph. Okay, so it follows, okay, x, so it's going to be ax cubed plus bx squared plus cx plus d. Okay, so the plus d is where it crosses on the y-axis. Okay, so I'll label that as my x. That's my y, x, and y. Okay, and then again, so cubic always has 3 roots. Okay, so we've got 1, 2, 3 roots actually. Okay, so cubic always has to have 3 roots. Okay, and a quadratic here must essentially always have like 2 roots. Okay, so remember from my previous videos that when you solve a quadratic, you always have 2 videos, two roots. Sorry, not videos, 2 roots. Okay, right, guys. Last one actually. Okay, so this is what I call a reciprocal graph. Okay, so this is in the form y equals k over x. Okay, so where like k is a constant. Okay, so the reason why it's like this actually, okay, is because, okay, we can't solve this essentially. Okay, so we actually can't solve this for x and y. Hence why it doesn't actually ever go or touch the axis, okay, because the y-axis is when x equals 0. Well, in maths actually we actually can't divide by 0 actually, so that's why it gets closer and closer and closer to the x-axis, y-axis, but never actually touches it. Okay, and similarly for the x-axis, when y is 0, well, I can't solve 0 equals k over x because it will imply that both k and x have to be 0, but they're not actually always going to be 0. K is certainly not going to be a 0, okay, because k is actually a constant. If k was 0, then there wouldn't actually be any roots to this to this graph, because 0 divided by anything is always going to give me 0. Okay, so this is actually what I call, like, these graphs are what I call like asymptotes. Okay, so this is like a mathematical word. So it means that it gets closer and closer and closer, but doesn't actually touch actually. Okay, so it gets closer and closer and closer to both axes, depending on which one you set to be 0. Okay, I can't set x to be 0 because I cannot divide by 0, and I cannot set y equal to 0 because I can't solve something divided by something equals 0, okay, unless they are both 0. But I specified that k is a constant, okay, it can't be a 0, so it cannot be equal to 0. So therefore that's actually impossible as well. Okay, so that was like a short video here on types of graphs. Okay, so thank you for watching, and I hope you subscribe to my channel. Okay, so more videos to come.